is Dr. Scott Spaniel. I'm a math professor at Morton College in Cicero, Illinois, and in this video we're going to talk about the mathematics of juggling. Juggling is simply a sequence of repeated tosses to create a pattern. These tosses and patterns can be represented numerically. For example, I'm currently juggling the 3-ball cascade, which can be represented by the number 3. The number tells me how long after each ball is tossed it will take before it gets tossed again. So in this case, every time I toss one of these balls, it gets tossed again 3 tosses later. So in other words, 2 tosses happen in the middle. Let's talk more about what these numbers all represent. A 0 represents an open hand. 1 represents a short toss from one hand to the other. 2 is a held ball. 3 is these cascade tosses I was doing, and a 4 is a short toss in one hand, and so on. In general, even tosses are to the same hand. Odd tosses are between hands. And in practice, the higher the number, the higher the ball has to go, because more things are happening before that ball gets tossed again, so the higher you throw it, the more time you have to do those other tosses.
One way to examine juggling patterns is to write out a long repetition of the sequence and then draw curves to follow the different objects through the pattern. So for example, the pattern I was just juggling, we said, was called 3. And so that's just a repetition of the toss 3 over and over and over again. So we can write out a fairly long sequence of repetitions of 3. And then we can follow objects through this. So for example, if we start with an object here with the first tossed, then that object goes 3 tosses into the future. So we can count 1, 2, 3, and this 3 is where it would get tossed again. And then we can count 1, 2, 3, gets tossed again, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, and then we run out. So because we're just doing the same thing over and over again, we just count 1, 2, 3 each time, gets tossed 3 into the future, and there's our first object getting tossed through it. Now we still have tosses left, which means we need at least one more object. So we start with the first number that we haven't used on the left, and we can do the same thing. We count off however many tosses into the future the number is in that position. So this is a 3, so we count 3 again. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and then we'd run out. So we can follow that object or ball through the juggling pattern. Okay, and we still have numbers left, so that means we need at least one more object. So we start with the first one that's open, and we count 3 right again because it's a 3. So we count 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And so there's our third ball. And so now we can see that all of these balls are being tossed exactly the same each time, and that we need 3 objects to juggle this pattern. So let's try another one. So another fairly common juggling pattern is called the fountain, and it's represented by the numbers 5, 1. So we throw a 5 and then we throw a 1. 5, 1, 5, 1, back and forth. Okay, so we can write that out. We just repeat 5, 1, 5, 1 over and over again, as many times as you want. You want to do at least a few repetitions, but you can do as many of them as you want. So we start once again with the first number, and we count off how many tosses in the future. So that'd be 1, 2, 3, 4, 5, and then 1, and then 1, 2, 3, 4, 5, and then 1, 1, 2, 3, 4, 5, and then 1, 1, 2, 3, and we run out. So this first ball gets thrown high in the air, and then a short toss from one hand to the other, then high in the air, short toss, high in the air. We still have numbers left, so we need at least one more object. So we start with the first number we have left over. It starts with a 1 and then a 5. So 1, 2, 3, 4, 5, and then 1. 1, 2, 3, 4, 5, and then 1. 1, 2, 3, 4, 5, and then 1. And then 5 would be off the end of our sequence, so it would keep going. We can connect those. So short toss, high, short toss, high toss between hands, short toss, high toss. Still have numbers left, so we need to do at least one more object. So we start with the first number left on the left-hand side. So we do 1, then 5, then 1, then count 5. So 1, 2, 3, 4, 5, 1, 5, and then 1. And so once again, we can see we don't have any objects trying to land in the same place together. So this thing can be juggled, which we expect because this is a pretty well-known sequence. And we don't have any, and once again, we need 3 objects to be able to juggle this because we have 3 different colors we used, right? We can see the 3 objects being juggled through this pattern. So after this, you can just start making up number sequences you want. You can really use any set of numbers you want. We could try another one, another couple together. So another juggle sequence that can be juggled is 5, 6, 1. So this one has 3 numbers in it, but we just do the same thing, right? 5, 6, 1, 5, 6, 1, 5, 6, 1, 5, 6, 1, 5, 6, 1, 5, 6, 1. So same idea as before, right? We just count them off. And so now let's follow the objects through this one. So we start with the 5 and we count 1, 2, 3, 4, 5, land on the 1, count 1, then count 1, 2, 3, 4, 5, 1, 1, 2, 3, 4, 5. Okay, so there's one object going through this sequence. Okay, so then we start with the first number we haven't used yet, so that's this 6. And so we count 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and then we're going to run out. So those are some really high tosses in the air. Still got numbers left, so we need another object. So we start here with this 1, count 1, and then count 5, 1, 2, 3, 4, 5, count 1, 1, 2, 3, 4, 5, count 1, and then so on. Okay, whoops. And in this case, we still have some number left, so we need to go at least one more object. So in this case, we're going to use at least 4 objects if this can be juggled. So we start with the first number we haven't used, which is the 6. We count 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And so in this case, we still don't have anything running into each other, so this is still a juggable sequence. But we can see in this case we needed 4 different objects to be able to juggle this. So let's try one more together. Let's just make up a sequence. So how about 5, 1, 3, 2? Okay, so this has 4 numbers in this sequence. So 5, 1, 3, 2, 5, 1, 3, 2, 5, 1, 3, 2, 5, 1, 3, 2. Okay, so we can start with the first object here again. So count 5, 1, 2, 3, 4, 5. Count 1, count 3, 1, 2, 3, count 1, count 3, 1, 2, 3, count 1, count 3. So this ball object would go like this: 1 big, 1 short, 1 medium, short, medium, short, medium. So we need another object. So then we got 1, count 1, 3, 1, 2, 3. Oh, and here we run into a problem. Now we've got 2 objects trying to land in the same hand at the same time. So that means that this sequence cannot be juggled, because you cannot catch 2 objects at the same time in one hand, at least not on purpose when doing one of these sequences. So that would be an example of a sequence that can't be juggled. These other 3 could be. So now, if you wanted to, at this point, would be a good time to pause the video and try these on your own. And see if you can come up with your own sequences and follow the objects through the sequence and find out if they can be juggled. Now there is, now that you've tried some of those, there is a really fairly easy method for deciding if a sequence can be juggled fairly easily, and it uses what is called modular addition. So the idea behind modular numbers is that you've got the whole numbers, so the whole numbers, are 0, 1, 2, 3, 4, 5, 6, 7, 8, and so on. And what modular numbers do is they limit which numbers you're allowed to use by telling you how many whole numbers you can use starting from 0. So, for example, mod 4 would mean you can use the first 4 whole numbers, versus mod 6 means you could use the first 6 whole numbers. Okay, so when you're dealing with modular numbers and you plug the numbers start as we would kind of expect them to start. Okay, so we've got 0 in mod 4 would just be 0. 1 mod 4 would be 1. 2 mod 4 would be 2. 3 mod 4 would be 3. But then once I run out of numbers, right, because mod 4 I'm only allowed to use 0, 1, 2, and 3, I start back over at the beginning. So 4 mod 4 would be 0. 5 mod 4 would be 1. 6 mod 4 would be 2. 7 mod 4 would be 3. And 8 mod 4 would be 0, right? Because I ran out of numbers again. Similarly, same thing would happen with mod 6, right? 0 mod 6 would be 0. 1 mod 6 would be 1. 2 mod 6 would be 2. 3 mod 6 would be 3. 4 mod 6 would be 4. 5 mod 6 would be 5. Notice that I was able to use 4 and 5 because in mod 6 I'm able to use up to the 6th number in the sequence, which is the number 5. And then 6 mod 6 is where we would start back over at 0. So we can use these modular numbers to check to see if our sequences are juggable by adding the juggle number to the position and then modular how long the sequence is. And if we get any repetitions in answers, that means it can't be juggled. So let's take a look at the sequences we used so far here, right? We looked at 3, we looked at 5, 1, we looked at 5, 6, 1, and we looked at 5, 1, 3, 2. Okay, so in this first sequence, so their positions, just like with the modular numbers, start at 0. So 3 would be in position 0. Here the 5 would be in position 0 and the 1's in position 1. Here the 5 is in position 0 and the 6 is in position 1 and the 1 is 2. And then here the positions are 1, 0, 1, 2, 3. And then for this first one, we're going to be adding mod 1 because there's only one number in that sequence. The second one has 2 numbers in the sequence, so that'll be mod 2. The third one has 3 numbers in the sequence, so that'll be mod 3. And the fourth one has 4 numbers in the sequence, so that'll be mod 4. And so what we can do is we can add these two numbers together. 3 plus 0, mod 1. So that'd be 3 mod 1. Okay, and then we just need to look at, well, what would the numbers, with mod 1, you're only allowed to use one whole number, so the answer is always going to be 0. And in fact, any one number sequence is always juggable because there's no way to repeat it because there's only one number in the sequence. Okay, so then with the second one, we would take 5 plus 0, mod 2, and 1 plus 1, mod 2. So that would be 5 mod 2, and 2 mod 2. And then we probably need to look at what the numbers are mod 2. So we got 0 mod 2, 1 mod 2, 2 mod 2, 3 mod 2, all the way up to 5 because that's one of the answers we need. Right, like that. So 0 mod 2 would be 0, 1 mod 2 would be 1, but now I have to start back over, right? Because I'm only allowed to use 2 numbers. So 2 mod 2 is 0, 3 mod 2 is 1, 4 mod 2 is 0, and 5 mod 2 is 1. Notice I only get to use 2 whole numbers, so I'm using 0 and 1. So 5 mod 2 was 1, 2 mod 2 is 0, right? 5 mod 2 is right here, 2 mod 2 is right here. These are both different, So we can juggle this pattern, which is what we saw when we wrote out the sequence, right? So let's go ahead and try these other two together. So we'd have 5 plus 0 mod 3, 6 plus 1 mod 3, and 1 plus 2 mod 3, right? We're just adding these two numbers together. 5 plus 0, 6 plus 1, 1 plus 2. So that'd be 5 mod 3, 7 mod 3, and 3 mod 3. And once again, let's look at the pattern so that we know what these numbers are. So we start with 0, so 0 mod 3. Here we're allowed to use 3 whole numbers, so that would be 0. 1 mod 3 would be 1. 2 mod 3 would be 2. But now I'm out of whole numbers, so I have to start over. So 3 mod 3 is 0. 4 mod 3 is 1. 5 mod 3 is 2. 6 mod 3 is 3. And 7 mod 3 would be 0. Oh, sorry. Screwed that up. I used the whole number I'm not allowed to, so I went too far. 6 mod 3 is 0, and 7 mod 3 is 1. So if we look here, 5 mod 3 is 2. 7 mod 3 is 1. And 3 mod 3 is 0. They're all different. So just like we saw when we wrote out the pattern, that can be juggled. And so finally, let's look at our last one here. Right, so we've got 5 plus 0 mod 4, 1 plus 1 mod 4, 3 plus 2 mod 4, and 2 plus 3 mod 4. Okay, and so here we've got 5 mod 4, 2 mod 4, 5 mod 4, and 5 mod 4. And if we look back up at the top, up here we already did the mod 4s, right? We listed those out when I was talking about modular numbers. So 5 mod 4 is 1, 2 mod 4 is 2, 5 mod 4 is 1, and 5 mod 4 is 1. These are all the same, so this cannot be juggled. This is a sequence that cannot be juggled. So now if you want, you can pause the video here, look at the sequences you tried out earlier, and see if they fit using this these modular numbers in this modular addition. And if you're interested in the more details of why this works the way it does, or the more detailed math behind any of this, check out the paper that is linked along with this video that describes all the math me and my fellow grad students at Eastern Illinois University did to prove the stuff we're doing here today. There's also technology available out there to help us visualize and to check and see if these patterns can be juggled. This one that I have here is called Juggling Lab. It's free on the internet, a free program you can download for PC or Mac. And so we can look at how to juggle these. You simply put in the pattern you want to see juggled, click juggle, and there you can see it. So here's the 3-ball cascade I was doing at the beginning of the video. Another one of the patterns that we tried was the 3-ball shower fountain. Fountain that we showed could be juggled, and so that's what this would look like. 5-1. We also tried the pattern 5-6-1, and so that's what this would look like. 5-6-1. So that's a much more difficult pattern to actually juggle with 4 balls. And then we also tried to do the pattern 5-1-3-2, and notice what happens when I try to hit juggle. It tells me invalid pattern average, so that's a pattern we can't juggle. So if you want to visualize these patterns that you may have come up with, feel free to download a program like this and give that a try. Thank you for joining me as we've examined the mathematics of juggling. Once again, I'm Dr. Scott Spaniel from Morton College in Cicero, Illinois, and I hope you found this video to be informative and engaging.